Okay, today we want to talk about simultaneous equation. There are several ways to go about simultaneous equation, but our focus will be on substitution method, elimination method, and Cramer's rule method. The Cramer's rule method is not the easier one or the well-known rule or method that we've known previously in solving simultaneous equation. So I'll be teaching you how to make use of substitution method, elimination method, and Cramer's rule. Let's go straight to business. I will just solve one example. We have x plus y is equal to 2. 3x minus 2y is equal to 1. We'll focus on this example using all three rules to see if we could get same answer. Let's start with the substitution method. Now, in simultaneous equation, we want to solve for two variables, x and y, simultaneously. That is, as we are solving for x, we are also solving for y, so as to get it. That is what it means, simultaneous equation. Now, for my substitution method, x plus y is equated to 2 as my equation 1. 3x minus 2y is equals to 1 as my equation 2. Now, in substitution method, with the word substitution, coming from the root word substitute, I will say from equation 1, I will make x subject of my formula. X is equated to 2, y goes over to become what? Minus y. I'll call this my equation 3. I picked equation 1 because it is easy when we want to make x subject of the formula. Now, I've gotten my x to be equated to 2 minus y. I can say substitute x in equation, let's say 2, in equation 2. Now, this is my equation 2. Wherever I see x, I replace with 2 minus y. This is 3 brackets of 2 minus y in place of x. Minus 2y is equated to 1. Now, opening up this bracket, we have 3 times 2, 6, minus 3y minus 2y is equated to 1. Now, having seen something like this, we collect like terms where we have the y one side minus 3y minus 2y is equal to, we maintain our 1, and then our 6 goes over to become what? Minus 6. Okay, I'll clean up this. And then, going further to solve, we have this to be minus 5y is equal to 1 minus 6 is what? Minus 5. And then our y is equated to 1 when you divide both sides by the coefficient of y, which is what? Minus 5. Now, we continue. We've gotten our y. Now, because we have equation 3 where it is simpler to place y, we go back to say substitute y in equation 3. This is my equation 3. I will substitute y. X is equal to 2 minus our y is 1, and x is equal to 2 minus 1, and minus 1 is what? 1. Therefore, x is equal to 1 and y is equal to what? 1. So in the equation, x is equal to 1 and y is equal to 1. If you want to cross check, if you want to verify, this is it. X plus y is equal to 2, meaning 1 plus 1 is also equal to 2, which is correct. From our second equation, 3x minus 2y is equal to 1. 3, 1 minus 2, 1 is equal to 1. We have 3 minus 2 is equal to 1, which is also correct. Now, let's check all this solving using the elimination method. Okay, now I want to deal with elimination method. We've done the substitution method. Our x was 1, y was 1. Now let's confirm if elimination method can lead us there. Now this is our formula, equation. We are substituting this for equation 1. As elimination signify, we eliminate the x to get y. The y is being eliminated later on to get the x. Now equation 1 and 2. Now in elimination method, what you do is to make either the coefficient of x the same or the coefficient of y the same, provided that the sign is the same. Now that for x, the signs are the same, plus plus. That for y, the signs are different, plus minus. So in order not to get issues, deal with that of what? The x. And now this is 3. The coefficient of x in equation 2 is 3. The coefficient of x in equation 1 is 1. So we have to what? Make it align. That is why I will introduce this equation 1 times 3. It will give me 3 times x, 3x, 3 times y, 3y. 3 times 2, 6. I will call this my equation 3. And then I will say equation 2 times 1. Now I'm picking the coefficient of equation 1x to multiply with equation 2. I'm picking the coefficient of equation 2x to multiply with equation 1. That is what I just did, times 3, yeah? Times 1 from here. And then I will have 3x minus 2y is equated to 1. I will call this equation 4. Now why I'm doing so, because I want to do equation 3 minus equation 4. I'm subtracting both. Now the aim of doing all of this is because my 3x minus my 3x, it is out. These two are out. Now this 3y minus 2y becomes 5y. 3y minus 2y, minus times minus plus, so 3y plus 2y is what? 5y. Let's continue. Now we have 6 minus 1, which is what? 5. Then we divide both sides by 5, and then my y becomes what? 1. When all of these divide each other, my y is 1. Okay, don't rejoice yet. Let's confirm if my x can give us 1. Now substitute y in equation, let's say equation 1, and then my equation 1, jumping back to my equation 1, this is x plus y is equal to 2. Sorry, my y is 1. X plus 1 is equal to 2. Rather than placing my y, I make it what? 1. Now x is equal to 2. This crosses over, minus 1. X is equal to 1. Therefore, x is equal to 1 and y is equal to 1. That leads us back to our solving in substitution method. And elimination method is confirming that x is 1 and y is 1. Okay, Cramer's rule wants to confirm that substitution and elimination are correct in their method. Now, this is a bit different. It is actually coming from matrices and determinants. That is where Cramer's rule is coming from. Don't worry, in my next video, you'll see that of matrices and determinants. You are going to see the solving, the overview of matrices and determinants, where I'm going to cover Cramer's rule as well. But let me still use Cramer's rule to what? Confirm this particular question. Now, this is how it works. In Cramer's rule, take the coefficient and make it in a matrix form. This is what we do. Now, the coefficient of xy, and then the 2 and 1, we create a row and column for them. The coefficient of x here is what? 1. The coefficient of y there is what? 1. The coefficient of x here is what? 3. The coefficient of y there is what? Minus 2. This is my matrix. This is my matrix format for this particular space. Now I'll create another space for x and y. This is my x and y, the two variables, and then they will be equated to what we have here, 2 and 1. That is what Cramer's rule requires us to do. Now, in solving Cramer's rule, I like labeling my matrices. Now, for matrix, this is 2 by 2 matrix, whereby you have 2 rows and then 2 columns. Now, I can name this matrix A, matrix B, or rather matrix C and matrix B, because it's actually X and Y that we are looking for. Now, in Cramer's rule, it's supposed to be in this pattern. The inverse of matrix A times matrix B will be equated to matrix C. That is what Cramer's rule is all about. Now, how do we place all of this and get X and Y? Yes, you'll be thinking, how is it possible? Now, this is how we go. Firstly, let's treat this A and get the inverse of A. To get the inverse of A in a matrix form, you have to get the determinant and then switch your diagonals. Let's do that. Now, our A is equated to 1, 1, 3, minus 2. Now, the first thing we do, let's get the determinant of A. Determinant is written as this. It's written as this, and then the determinant, it is diagonal minus diagonal. This is the first diagonal, then this is the other diagonal. Now, 1 times minus 2 is what? Minus 2. Then we have our minus 3 times 1 is what? 3. The determinant is what? Minus 5. Now, this is the determinant. The next thing we do is the inverse. For we to get our inverse, we are going to do our determinant 1 over determinant. Then your first diagonal switches place. Your minus 2 goes up, your 1 comes down. That is your first diagonal. This is the first diagonal. This is the second diagonal. What we are dealing with is the first diagonal. We switch the place, minus 2 and 1. Now, the second diagonal, we leave it where they are, but we add a negative sign to it. The 3 will become minus 3. The 1 will become minus 1. That is what it requires for you to get the inverse. Now, this is not all. You use your scalar. These are called scalar. You use your scalar to multiply your matrices. At the end of the day, you have something like this. 1 minus 1 over 5 times 2, it is 2 over 5. Minus 1 over 5 times minus 2. Minus times minus plus 1 times 2, 2 over 5 times 1, 5. That is what I'm doing. Now, if I want to do same for this, I will have 3 over 5. With what I just showed you, you can be able to have 3 over 5. The minus, we delete the minus. Now, for this same thing, we have what? A positive 1 over 5, because there is minus already at placing 1. Now, the next one, there is minus here. There is no minus. We have a negative 1 over 5. And then, having done this, this becomes our inverse of A. Okay, since we've gotten our inverse of A, we are almost there. Okay, let's continue it here. Now, this is our inverse of A. And the next rule is the inverse of A times B, which is going to be like this. This is my inverse. I'll bring down my inverse 2 over 5, 3 over 5, 1 over 5, and then negative 1 over 5 times A and times B. And this is my B. This is my B, which is what? 2 and 1. Now, for we to do the multiplication, in multiplication of matrices, we multiply row for column. That is, we are multiplying like this for like this, and then that forms row 1, column 1. For example, we are dealing with 2 over 5 times 2. One side plus 1 over 5 times 1. Then this, we still do the same thing. This for this. 3 over 5 times 2. plus minus 1 over 5 times 1. Now this will give me, this is going to give me, if I want to do this, 2 times 2 over 5, it is 4 over 5. Plus 1 over 5 times 1 is what? 1 over 5. Now this other one, 3 times 2 is 6 over 5. Now plus times minus, minus 1 over 5 times 1 is still 1 over 5. This will give me 4 over 5 plus 1 over 5. 4 over 5 plus 1 over 5. It is 5 over 5, which is what? 1. So this will give me 1. 6 over 5 minus 1 over 5. It is 5 over 5, which is equals to 1. So A inverse times B will give me 1 over 1. And then the last part said, A minus 1 times B should be equated to C. If I should bring down everything, this is A minus 1 times B, which is 1, 1. And then it should be equated to what? C. And our C is what? X and what? Y. Therefore, X is equals to 1 and Y is equals to 1. So both substitution method, elimination method, and Cramer's rule gave us same answer, x1 and then y1. Okay, I haven't done that. Now you try this. Solve 2x minus 4y is equated to 4. 5x plus 8y is equated to 3. Use both substitution method, elimination method, and Cramer's rule to see if you can be able to get your answer in accordance. Remember, please subscribe to Cheriano Tutorials. See you in my next video.